Good evening. This is Kavipriya, Assistant Professor, EC Department. Today I am going to present a topic, block diagram of digital communication. So this is a block diagram of communication system. So general typical communication system. So we'll be having a source and we'll be having the sink and we'll be having a transmitter and receiver. So transmitter and source at the one end and the receiver and the information sink at the other end. Data will be transmitted from transmitter to receiver through the channel. So source is a person who sends a data and the sink is a person who receives a data. And this is a block diagram of digital communication. The information data from the information source, which is in analog form, will be converted to the digital using this A to D converter, and it is encoded using the source encoder, and it is given to the channel encoder, and output of the channel encoder is given to the modulator. So modulator data will be transmitted through the channel, and the receiver will be having a demodulator, channel decoder, source decoder, and D to A converter, and the information sink. So the information source is nothing but it can be analog data or it can be a digital data. Analog data sources are microphone, speech signal, image, video, etc. Whereas digital data will be sent through the keyboard, or it can be a binary numbers, or it can be a hexadecimal numbers. So next block is the analog to digital converter. Here the analog data will be converted to digital signal by three processes. First one is sampling, second one is quantization, and third one is a coding. Sampling is a process of converting a continuous time signal to a discrete time signal, whereas it is discrete in time. So discrete in amplitude is done by the process called as a quantization. So after performing the quantization, the continuous time signal will be at the end of the quantization, the continuous time signal will be converted to the discrete time signal. So later we'll be assigning a binary code to each and every finite amplitude in the coding part. So the result of a coding is a digital signal. And next is a source encoder. The source encoder represents the transmitted data more efficiently, and it removes the redundant information. There are two types of encoding. It can be a lossless data compression or it can be a lossy data compression. So lossless data, in case of lossless data compression, data can be recovered without any missing information. Whereas in case of lossy, there will be some error, some loss in data. So data removed in encoding cannot be recovered again, and the data will be in smaller in size in case of a lossy data compression. We can compress the data to the maximum, but there will be loss in the data. And next is a channel encoder to control the noise and to detect and correct the errors that occur in the transmission is done through the channel encoder. And next is a modulator. Modulation is a process of transmitting the data for transmitting a data to a longer distance. We'll be modulating the signal. We'll be combining the carrier signal along with the message signal and will be transmitting. So represent the data in a form to make it compatible with the channel is done by the modulator. And next is a demodulator. Remodulator is a reverse of modulator. In modulator, we'll be combining the carrier signal and will be transmitting. Whereas in case of demodulator, we'll be removing the carrier signal from the message signal. And this is a reverse of a modulator. Next is channel decoder. Channel decoder detects and corrects the errors in the signal gained from the channel. Source decoder decompresses the data into its original format. And next is a D to A converter. D to A converter reverses the operation of A to D. Needs techniques and knowledge about the sampling and quantization and coding method. And next is the information sink, which is the user. So why we should go for a digital communication? Because it is ease of regeneration of a signals, because the signals are represented here in forms of zeros and ones, and also it is very easy to use the repeaters in digital communication, and it is better immune to noise. So noise immunity is very high in case of digital communication. Better noise handling when we use repeaters that repeats the original signal. It is very easier to differentiate between either 0 or 1s. And it is very easy to transmit here. Less errors, and it is very faster and better productivity. and it is very ease of multiplexing. We can transmit the several signals simultaneously, and it is use of modern technology in case of digital communication. So cost is also very less, and ease of encryption, security and privacy guarantee handles more of the encryption techniques in digital communication. Drawback is that major drawback of the digital communication is that it requires a greater transmission bandwidth or channel bandwidth to communicate the same information in digital format as compared to the analog format. Another drawback is that digital detection requires a system synchronization, whereas analog signals generally have no such requirement. So that's all about the block diagram of digital communication technique and block diagram of general communication technique, and also we have seen why we are preferring digital communication over the analog communication, what are all the advantages of a digital communication, and also what are the drawbacks in digital communication. Thank you.